Hello and welcome to Engineers Mindset Academy. So today we are going to be looking at the second topic, which is usually repeated in the previous JAMB examination question. So also expect this in the 2024 JAMB examination question. So we've done the first video. Do well to look up that video. I will also post the link of that video in the description of the video so you can watch it up for proper understanding. So as you all know, we are doing a series on both physics, mathematics, chemistry, covering all JAMB past questions, at least 3 years behind JAMB past questions for you. So at the end of each topic, we always treat at least 2 to 3 years previous questions in the JAMB examination, just to prepare you ahead of the 2024 JAMB examination. So do well to, of course, watch this video from now to the end to properly get all of that. All right, so the second topic we are going to be dealing with is linear momentum. Now, what is linear momentum? Linear momentum can be defined as the product of the mass of an object to the velocity or speed of the object. It is simply the product of the mass of an object to the velocity or speed of the object. Mathematically, momentum P, momentum P is equal to mass of any object multiplied by velocity or speed of the object. Velocity v. So we are simply saying that momentum is simply mass times velocity of an object. Now, the Newton's second law of motion actually explains the concept of impact in relationship to momentum. Newton's second law of motion simply states that the rate of change of linear momentum is directly proportional to the force applied on an object. The rate of change of linear momentum is directly proportional to the force applied on an object. So if we put that down mathematically, one would say change of linear momentum. It means that force, is directly proportional to the change of linear momentum. So we have mv minus mu all over t. So we are simply saying the rate of change, where mv minus mu simply stands for what? Change in momentum. Change in momentum all over time. So from Newton's second law, force is directly proportional to the rate of change. Rate there simply means time. So we have mv minus mu all over t. V simply means what? The final speed, and u means the initial speed, while m remains the mass of the body. So the rate of change of linear momentum is simply directly proportional to the force. So if we remove the proportionality sign, we're simply going to have that force is equal to, we introduce a constant k into mv minus mu all over t, where k itself is dimensionless and is taken as 1. K is equal to 1. So if we take this off, it simply implies that force is equal to the change in the final momentum minus the initial momentum all over time. And from here, we can actually make mass of the object subject of the formula or factor. We can factor out mass. It becomes m into v minus u all over t. So notice now that from this equation, from this part of the equation, we can simply cross multiply t multiplied by force, and we have that force times time is equal to mv minus mu. And this simply implies that force times time is equal to, not forgetting, mv simply means what? Momentum. Mu also means momentum. So mv is the final momentum, mu is the initial momentum. So this is simply what? Change in momentum P. And force times time itself is simply talking about a concept in physics called impulse or impact. It's called impulse or impact. Simply capital I. Now, the impulse on an object is simply a large amount of force which acts on a very short time. A large amount of force which acts on a very short time is simply called an impulse. So we are simply saying that impulse, I is simply equal to force acting on a short time. So force times time. So I is equal to F times T. And if you look at this equation, we have that force times time is actually change in momentum. So which means, remember, force times time is impulse, And change in momentum simply means, of course, mass times velocity, change in momentum. So this simply means that impulse, according to Newton's second law, the impulse on a body is equal to the change in momentum of the body. So you can simply say I is actually what? Change in momentum. The impulse on the body is equal to the change in momentum of the body. So if you're given, let's say a force of 50 Newton acts at a time 0.5 seconds, what then is the impulse? Simple. Force is given to you as 50 Newtons and the time there is given to you as 0.5 seconds. You ask the impulse. Impulse I is simply equal to what? Force times time, and you have, of course, force times time. Force there is 50 newtons, time there is 0.5, and if you do this, you're going to obtain that impulse itself becomes what? 25 newton seconds. The unit of impulse is the unit of force and the unit of time, which is newton and seconds. So the impulse there becomes what? 25 newton seconds. A large amount of force which acts at a very short interval of time gives us or tells us what is called an impulse. Whereas the mass of a body multiplied by the velocity of that same body or the speed of that same body tells us what? The momentum of the body. And in general, from Newton's second law, it was explained that the change in momentum of the body is equal to what? The impulse acting on the body. Now, let's consider a few other examples and see. Let's say we are given the mass of 50 kg of a body is moving at 10 meters per second. What is the impulse of the body? Okay, so you have mass to be equal to 50 kg of a body is moving at a speed v of 10 meters per second. Now, what is the velocity? Now, what is the momentum? Okay, so momentum P, remember, is what? Mass times velocity. Momentum is simply given as the product of mass and velocity. So all you need to do is what? Multiply these two concepts together or these two terms together. Mass is given as 50 kg. So you put it down, 50 multiplied, the speed of velocity is 10 meters per second multiplied by 10. So this simply implies that what? Your momentum P is now what? 500 kilograms meter per second. So you have this to be your momentum. So depending on what the question is saying, you can also be given momentum and you're asked to find speed when a mass is given to you, or you can also be given momentum and a speed and you're asked to find the mass. Same thing goes with the impulse. You could be given an impulse and you're asked to find time and all of that. Let's pick an example and see before going further into linear momentum. So let's say we are given a force of 100 newtons impact on an object with an impulse of 10 newton seconds. At what time did this happen? At what time did this occur? So we pick out our parameters. A force, okay, of 100 newtons impact on an object with an impulse of 10 newton seconds. Okay. Now we are asked to find what? Time. Time is what we are asked to find. Okay, so once again, you recall that impulse I is the product of force and what? Time. So you have force times time. You know the impulse and you know the force, but you don't know the time. You're asked to make time subject of the formula. So which means we need to make this subject, and therefore time is equal to, in order to make time subject, we divide both sides of this equation by what? The force. Okay, in order to make time to be left alone, divide both sides by force, divide both sides by force. So force cancels force, you're left with t here. So which means time t is equal to what? Impulse all over the force. So this simply implies that the time which this collision occurred, the time is simply given as, impulse was given to us in the equation as what? 10. You have 10 all over the force itself is what? 100. So 10 divided by 100. So the answer to this is actually what? 0.1 seconds. So you have it to be 0.1 seconds. So the time which this collision occur is simply 0.1 seconds. So depending on how the question is asked coming about, if you're giving impulse and you're giving force and you're asked to find time, just make time subject of the formula, you're good to go. If you're giving impulse and time and you're asked to find the force which acts on this body, you can simply go ahead and divide through by t, and of course you have I all over T to obtain the intensity of force acting on the body. All right, so these are just few tips or few things you also need to pay attention while preparing or writing your physics JAMB examination. These are few questions you could also expect, okay, because I've seen them over time in previous years being repeated. All right, but the main deal is conservation of linear momentum. Here is our key interest: conservation of linear momentum. The questions that have come out in recent time, this year 2023, and of course last year 2022, are all on conservation of linear momentum. So which is why it's of paramount importance for us in this particular video. Now, the law of conservation of linear momentum simply states that the sum of the momentum of objects before collision is equal to the sum of the momentum of the object after collision. It's as simple as that. The sum of the momentum of an object before collision is equal to the sum of the momentum of the object after collision has taken place. For instance, let's say I have two objects of mass. This object is object A, and I have another object here, object B, and they have their masses. Let the mass of this object be what? MA, and let the mass of this object be MB. Now let this object travel in opposite direction to themselves. I have this moving in this direction, UA, with a speed. Call this speed UA. Now we're using U to denote what? Initial speed. Okay, and let this object also move in this direction with its own speed, UB. They are moving opposite one another. Now, this is before collision. Remember, momentum is what? The product of mass and velocity. So this is now before collision. Before collision, okay, so in this case, they are still about to what? Yet to collide. They are moving towards one another, but they are yet to collide. Now, the total momentum before collision is equal to total momentum after collision from conservation of linear momentum. Now, let's say they finally collide. At the point of collision, you have these two objects hitting one another, something like this. You have these two objects. This is object A and this is object B. Okay, you have these two objects with their mass MA and MB. Now, this is at collision. This is what you experience at collision, okay? You have that these two objects collide with one another. What happens now is the object which has the higher mass will compel the other object to move in its own direction. For instance, if the mass of this object is 10 kg, or let's say this is 10 kg, okay? And the mass of this object is 5 kg, and this object, that's object A, is moving to the right. After collision, what happens is that since the mass of object A is bigger than the mass of object B, regardless of the speed, what matters is the quantity of matter there, which is what? Mass. Since the mass of object A is larger than the mass of object B, it means that the weight on A will be larger than the weight on B. So which means object A will cause object B to what? Move in its own direction. So after collision, this is what will happen. After collision, you have that these two objects now will travel in the same direction. So you have object A moving in this direction, object B also, this is A and this is B. You also have object B moving in this direction. Now this is mass of A and this is mass of B. Now they are moving with what? A final speed. And that speed is simply what? VA for what? Final speed. And then VB for final speed. So what happens is that this is now after collision. Okay, this is after collision. So after collision, the object which has a higher mass will cause the other object with a smaller mass to move in its own direction. Now, their speed in this point will reduce. Of course, the speed will reduce and will not be the same thing. Why? Simply because if this is moving at a speed of 10 meters per second and B is moving at a speed of 5 meters per second, or let's say 15 meters per second, after collision, there is an impact, a large amount of force which acts at a very short time. That will slow down the speed. It will slow down the speed, and then they will now move with a different speed. Now, that different speed is what we call what? The final velocity, VA and VB, and whereas UA and UB means their initial speed before collision. Now, at collision, you have then after collision, like I said, the object which has the higher mass will cause the other object to move here in its own direction. Now, having this, from the law of conservation of linear momentum, it simply says that the sum of the momentum before collision is equal to the sum of the momentum after collision. So notice that at collision have been neglected. So what we are paying attention to is what? Momentum before collision and momentum after collision. What happens? Now let's take a look at this now. We said that momentum is now mass times what? Velocity. So which means this object A has a mass of ma and a speed of ua. So from the principle of conservation of linear momentum, it says that the total momentum before collision must be equal to the total momentum after collision. So before collision, this object A, the momentum of this object, let's call that Pa. Remember, P stands for momentum, and that's equal to this object has a mass ma and is moving with a speed ua, which is the initial speed. Therefore, the momentum of object A, we call that Pa, means what? The mass of A multiplied by its speed, which is ua. So you have ma multiplied by what? ua. This gives us momentum of body A. Also, momentum of body B before collision, call that Pb, is also what? The mass of object B multiplied by the speed of object A, which is what? ub. So you have here mb multiplied by ub. You simply have this. Now, the law is simply saying that the sum of momentum before collision is equal to the total momentum after collision. And this is momentum of this object before collision, maua. You also have this to be the momentum of this object before collision, mbub. Therefore, total momentum becomes what? Adding them all up together, you have ma ua plus mb ub. So this gives us momentum before collision. This gives us momentum before collision. Now, after collision, what do you have? This mass or this object A now moves with a final speed of what? Va, and object B also moves with a final speed of what? Vb. But notice that the mass remains unchanged. The mass remains unchanged. Therefore, after collision, the momentum of object A, called that Pa, will now become what? Ma times, now is going to be what? Va, because V now becomes the new speed at which they are moving. Okay, same thing. Final momentum after collision for object B becomes same thing. You have mb times vb. So the law is simply saying that total momentum before collision is equal to the total momentum after collision. Now, after collision, what do you have? You have ma va plus mb v. So this gives you what? The principle of conservation of linear momentum. So with this idea, you can solve any problem at all in linear momentum. Let's take an example, then we can now do our past question review. Alright, so let's consider this question on the board to explain the concept of conservation of linear momentum. Then after this, we can dive straight towards reviewing about 2 years or 3 years past questions which are repeated in the JAMB past question, just to equip you for your 2024 JAMB experience. Alright, so the question says, an object A of mass 10 kg moves with a speed of 5 meters per second and collides with another object B of mass 5 kg moving at 3 meters per second. After collision, object A moves with a speed of 4 meters per second. What is the speed of object B? So it's as simple. Let's draw the diagram to denote this. We have an object A, okay, which moves at a particular speed. So UA is given there. Object A has a mass. MA is equal to an object A of mass 10 kg. So MA is simply 10 kg, okay, moves with a speed of 5 meters per second. So UA means 5 meters per second, okay, UA is equal to 5 meters per second. And then we have another object B, which is moving at a particular speed, UB, equal to the speed of object B is 3 meters per second, okay, and the mass of object B, MB, is given there, and collides with another object B of mass 5 kg. The mass of B is simply 5 kg, and of course, this is object B. Now, this is before collision. After collision, what happens? Simple ideology. Notice that object A has a higher mass than object B. So, which means the weight of object A will be larger than what? The weight of object B. This will cause object B to what? Move in the same direction of what? Object A. All right, so after the collision, you have the mass remains unchanged. Mass of A remains 10 kg. So this is object A, but now the speed will change. Object B will now move with a final speed. Object A, sorry, will now move with a final speed VA. And it was stated after collision, object A moves at 4 meters per second. So the speed remains 4 meters per second. Of course, object B will also be propelled to move in that same direction as object A, since object A has a higher mass than object B. Okay, so the final speed now of object B is unknown and we are asked to find this. Mass of B still remains unchanged, MB still remains unchanged, which is simply what? Which is 5 kilograms, okay? So mass of B remains 5 kilograms. So you have this. Now, this is before collision. At this point, the objects have not collided. So this is before collision. And this is after the collision has taken place. So we call this is after collision. Okay, so from the law of conservation of linear momentum, we said the sum of momentum before collision must be equal to the sum of momentum after collision for equilibrium to be achieved. So momentum before collision, remember, momentum of A, call that PA, is equal to what? Momentum is always mass times velocity. So momentum of A remains the mass of A, which is 10 kg, multiplied by the initial speed of A, which is 5 meters per second. And that gives you what? 50 kilograms meters per second. This is the momentum of body A. Also, momentum of body B, call that PB, is equal to also the mass of object B, which is 5, multiplied by the speed of object B, which is 3. And this will give us what? 15 kilograms meter per second. So this is the total individual momentum of these bodies before collision. Now, the law simply says momentum, total momentum before collision. So you have to add them all up together. Therefore, total momentum, okay, total momentum before collision is now equal to, you sum them all up together, you have for this case momentum of A, that's PA plus PB, and that's equal to PA momentum of A gave us 50 kilogram meter per second plus PB, which is momentum of B, gave us here 15 kilogram meter per second. So if you add them all up, momentum before collision gave us what? 65 kilograms meter per second. So you have this, it becomes momentum, total momentum before collision takes place. Now, after collision has taken place, their momentum values changes. After collision, you have PA becomes now mass of A times VA. So the mass of A remains 10 kg, it doesn't change. So you have 10 times the speed of A, the new speed now, which is the final speed of A, was given as 4 meters per second. So times 4. So PA after collision is equal to what? 40 kilogram meter per second. So you have this. Then for body B, the momentum after collision for B, PB, is now equal to mass of B, which remains 5 kilogram, multiplied by the speed of B, which is now unknown. This is what we are being asked to find, unknown. So mass times speed. You have the mass of body B times the speed of body B, which we don't know. So you simply keep this. Now remember the law of momentum. We have to now sum the total momentum after collision. The law of conservation of linear momentum simply says the total momentum before collision is equal to the total momentum after collision. So total momentum after collision, we've already found total momentum before collision to be this. Therefore, total momentum after collision, becomes now PA plus PB, which is the final values. And the final values are what? 40 kilogram per meter seconds. 40 kilogram meter per second is 40 plus, of course, this 5VB. So you keep it like this. Now, if we call this equation 1 and call this equation 2, if you wish, or you can simply state from the law, the two of them are equal for equilibrium to be achieved. Linear conservation of momentum. Momentum before collision equals momentum after collision. So we have to equate them together. That simply means that 65 which is total momentum before collision, is equal to 40 plus 5 VB, 40 plus 5 VB, which is momentum after collision. Therefore, send 40 over here, you have 65 minus 40. If 40 cross and equal to sign, it becomes negative. So it becomes 65 minus 40 equals, so we are left here with what? 5 VB. So 65 minus 40 will give us, obviously, 25 is equal to 5 VB. So in order to make velocity of body B subject, divide both sides by what? The coefficient of VB, which is now 5. So this simply implies that VB is equal to 25 divided by 5. So the speed of object B after collision is equal to what? 25 over 5 will give us 5 meters per second. So you have that the speed of object B is equal to 5 meters per second after the collision. So that's the simple idea behind conservation of linear momentum, or the conservation law. Simply, total momentum before collision equals total momentum after collision. Always keep in mind, momentum is what? Mass times velocity. Having these two things in mind, you can always tackle any problem in JAMB. Alright, so I'm going to pause the video here, then we can state out some past questions on JAMB 2023 and of course 2022 and if possible 2021, and then let's see how the questions come out and then how you can actually handle it in a very short and simple way. All right. Welcome back. All right, so we're going to be using these two past questions, JAMB 2023 and JAMB 2022 past questions, to explain the concept of linear momentum, which we've learned. So this is another thing to let you know that this particular topic should be a topic of interest while preparing for your forthcoming 2024 JAMB examination. Now let's start with the 2023 question. It says a lead bullet of mass 0.05 kg is fired with a speed of 200 meters per second into a lead block of mass 0.9 kg. Given that the lead block can move freely, the final kinetic energy after impact is, so we have different options, option A down to option D. Now, I understand that you do not actually have all the time to tackle any of this problem by stating from the very first principle, the diagrams and all that. So what will happen is this: I am going to draw the diagram correctly and explain everything I need to explain to you, but I will also show you in the process how you are going to tackle such a problem if you encounter it in your forthcoming JAMB. You don't need to draw all these diagrams in your exam. You just need a simple idea to what? Understand the whole concept and then solve your problems and you're good to go. Now, I will start with the diagrams anyways. So we have a bullet. Let's call this A. And then we'll have a block. Let's call this B. Now, the bullet of mass, the mass of bullet was given to us. A bullet of mass 0.05 kg, and the mass of the block was given to us, okay, as 0.95 kg. Now, the bullet is moving with a speed u is equal to 200 meters per second. Okay, so take note, whenever the second object, the speed of the second object is not given before collision, whenever the speed of the second object is not given before collision, automatically its speed is 0. So since the speed of object B is not given before collision, it means that the initial speed of this object u or ub is equal to 0. So that simply tells you that this particular object B is at rest and it is not moving. Object B is at rest and it is not moving. So keep that in mind. Whenever the speed before collision, whenever the speed of a particular object is not given, that particular object has a speed of 0, which means that object is at rest. Okay, now this is before collision. After collision, this is what you have after collision. Notice that the mass of the bullet is 0.05, whereas the mass of the block is 0.95. So which means the mass of the block is bigger than the mass of the bullet. But in this case, the block is at rest and not movable. Since it's at rest, that means this bullet will collide with this block, and the both of them will actually what? Remain in one position or move up in the direction of what? Block B. But in this case, we are not given the direction of the block, so you can either keep them in this manner, but they are moving at a certain speed, which is what the question is asking us to find. Now, the mass of A remains MA, mass of B remains MB, okay, and of course, MA was given as 0.05, and this was given as 0.95. Now we are asked to find their common speed. So when they say find the common speed, it means that the both of them move off together at the same speed. Okay, it means that the both of them move off together at the same speed. We are asked to find their kinetic energy. Sorry, the question says we should find the kinetic energy after the impact. So after impact, it means that they both move up at a common speed, the same speed, nothing changes. Remember, this block does not have a speed in the first instance. So which means that speed now becomes a common speed. They will move at the same speed. All right, so we have to now look for one single speed, which we can simply call V. Call that V. That's the final speed or the common speed between the two of them. This is the diagram. You don't need to draw this actually. In an exam condition, you don't need to draw this. All you need to do is this. Before collision, calculate total momentum. What is total momentum before collision? Okay, before collision, okay, total momentum before collision, you have this simple. All you need to do, remember, the mass of the bullet multiplied by the speed of the bullet. Mass of the bullet is what? 0.05 multiplied by the speed 200 plus the mass of the block multiplied by its speed. Now, unfortunately, the block does not have a speed. So, which means the mass, which is 0.95 multiplied by the speed is what? 0. This is equal to, all right, so 0.05 multiplied by 200 simply gives us 10 plus, of course, 0.95 multiplied 0 still remains 0. So which means before collision, momentum is simply 10 kilogram meters per second. Now, after collision, momentum after collision simply becomes what? Again, remember, mass of object A, which is now the bullet, multiplied by the speed. So it's supposed to be mass of bullet, which is A, multiplied by the speed, which is VA, plus mass of block B multiplied by the speed of the block B. But I said that for if you're given a condition, then in a situation where one of the block or the second block, which is in this case now, is at rest, which means it doesn't have a speed. It means that after collision, what happens? The two blocks will move in the same direction because this object is at rest. So if this hits this object, it will not compel this object to now move in its own direction. So they will move off in the same direction and they will move at the same speed. If they are moving at the same direction, which means they are also moving at the same speed afterwards impact. So that speed is called a common speed. So we simply call it what? V. And therefore, this is now equal to, so that simply means that VA is equal to V and also VB is also equal to V because they are the same word speed. You move at the same speed after the impact. So we have now mass of A remains 0.05. So you have 0.05 multiplied by the speed of a VA, but VA and V are what? The same, common speed, because this object was at rest. So you have multiplied by V plus mass of block B remains 0.95, doesn't change. So you have 0.95 multiply also by what? VB, but VB is same as what? V, because they move at the same speed. So you have V. Therefore, after collision, final momentum becomes 0.05 V plus 0.95 V. That will give us 1 V, or you simply call that what? V. Now, from this principle of conservation of linear momentum, momentum before collision equals total momentum after collision. And the total momentum before collision will obtain 10. So this simply implies that 10 is equal to total momentum after collision will obtain V. So equals V. So this now implies that V itself is what? 10 meters per second, which is now the speed, the final speed or the common speed after what? The momentum or after impact. But the question says we should find what? The kinetic energy after the impact. So you now recall that kinetic energy is actually what? 1/2 mv squared. So this is equal to, now this mass becomes 1/2 becomes what? The mass of the two blocks, which is mass of A plus mass of what? B times their common speed all squared. So this is now equal to 1/2 times mass of A gave us 0.05 plus mass of B gave us 0.95, okay, multiplied by the common speed squared, which is now 10 all squared. So this is equal to 1/2 multiply 0.05 plus 0.95 is actually 1 multiplied 10 squared gives you 100, and this is about, of course, 100 times 1 is 100 all over 2. So this implies that the final kinetic energy is equal to 100 divided by 2 gives you 50 joules. So the correct answer is 50 joules. And if you look through the option C gave us 60 joules, which means the correct option is option C for that given question. Okay, so let's look over to the 2021 question. All right, so the 2021 question says a ball of mass 0.5 kg moving at 10 meters per second collides with another ball of equal mass at rest. If the two balls move off together after impact, calculate their common velocity. Okay, so now in this particular question you have that a ball of mass, I will also draw a diagram. Okay, so let me draw the diagram, but then you don't need to draw the diagram as I keep on saying. This is something you can actually punch to your calculator. Just understand the concept of the principle of conservation of linear momentum, and then you're good to go. But then let me also draw a diagram to simply explain. We have a ball of mass. Let's call that ball A. Its mass was given, call it MA, as 0.5. A ball of mass A is 0.5 kg moving at a speed of 10 meters per second. So UA is equal to 10 meters per second. Collide with another ball of mass of equal mass. So take note of that word. Another ball, this is ball B. Call this ball B. Now the mass of B, it says collide with another ball of equal mass. So which means the mass of ball B is equal to the mass of ball A. So which means MB is also equal to 0.5 kg. Now collide with another ball of equal mass at rest. So if it is at rest, it means that its speed UB is equal to what? 0. It is not moving. So that brings us to the idea I was explaining over here in this particular question. If a ball is at rest, what happens is that after collision, these two balls will now move in the same direction with what? A common speed. They will move in the same direction with the same speed or a common speed. So after collision, you have something like this. This ball and this ball will move off in the same direction with a common speed. So we simply call that speed V. We don't know. So it's not going to be velocity of ball A or the final speed of ball B. No, it won't be a final speed of ball A or final speed of ball B. They will now move at a common what? Speed. So which means the speed of ball A, which is VA, and speed of ball B, which is VB, will be equal to what? This common V velocity, which is V. All right, so the mass of A obviously remains the same, which is equal to 0.5 kg. Same thing as MB, also equals 0.5 kg. So you have this. Now, having achieved this, the both masses are equal. Of course, you have this is not the diagram. Like I told you, you don't need to draw the diagram. All you need to know is what? Apply the principle of conservation of linear momentum. Now, let's do it and see. So you can actually do that with your calculator. Now, before collision, you sum the entire momentum together. Before collision, you have momentum is equal to, remember, mass of A times speed of A. Mass of A is 0.5, its speed is 10. So you have 0.5 multiplied by 10 plus, now also mass of B, remember that B has the same mass as A. So it still remains 0.5 multiplied by the speed of B, but ball B was at rest. It doesn't have a speed, so its speed is what? 0. So multiply this by what? 0. So this simply means that before collision, total momentum is equal to 0.5 times 10, which is 5, plus 0.5 times 0, which is 0, and 5 plus 0 remains what? 5. So you have 5 kilograms meters per second. This gives you momentum before collision. Now, after impact or after collision has occurred, since this ball is at rest, it means the two objects will move at the same speed after collision. Hence, after collision, you find their total momentum as well. After collision, total momentum is now equal to, remember, mass of A, momentum of ball A becomes the mass, which is 0.5, multiplied by the velocity of A, which is VA, but VA now is equal to what? V. After collision, since this ball was at rest, they move in the same direction with the same speed, and that common speed is what we call what? V. So which means these two speed remains same. So VA is equal to V. You simply call that V, which is the common speed, plus then again the mass of ball B, which also remains what? 0.5, because ball B has is of equal mass with A. Okay, so you have 0.5 times VB, which is the speed of B, but VB is the same thing as what? The common speed. They move with the same speed after collision or after impact. So you see, simply write that down as what? V. Now 0.5V plus 0.5V will simply give you V. You see that after collision, you have what? V to be the what? Momentum. And from the principle of conservation of linear momentum, the final momentum is equal to the initial momentum. What is the momentum before collision? We have 5. And what is the momentum after collision? You have what? V. And V there stands for the common velocity. So this simply implies that V itself is 5 meters per second. So that becomes the answer. And if you look through the option C has 5 meters per second. So which means the correct answer or the common velocity after the impact is what? 5 meters per second. All right, guys. So that's it on that particular question on JAMB past question review. Now we'll review 2023 and 2022 past question on linear momentum. So this is also going to tell you that momentum is a key topic which you need to watch out for in your upcoming JAMB. And I hope this video helps you to understand the concept and the tricks, how they set their questions, so that you can actually succeed in your forthcoming JAMB. Now, like I said, you don't need all of these diagrams. All you need to do is what? Know this. You can even punch this with your calculator and you have your answer in less than 10 seconds. Okay, and then you can move on to the next question. So I'll end the video here, and in the next video we'll come up with a different topic, okay, that is repeated yearly in JAMB, and then just like here we'll do explain the topic and then of course end it with what? Past questions. So if you're new to the channel, do well to always like our videos, comment, and of course subscribe to the channel to have the updates when the new video will drop. Okay, I'll see you in the next video. Thanks and cheers.